Let's prepare on slope and deflection. So today we are going to see about the slope and deflection values for various type of frames. Okay, so this will be helpful in all the methods of analysis of indeterminate stresses, especially in the stiffness matrix. In that areas and all it will be useful. Okay, so this chapter we have already seen in the strength of materials. So the same picture only I am given here. So we have seen some 6 type of beams, and for that beams the slope and deflection, and the trick to remember that also we have seen in that video. Okay, so I don't want to repeat that again. I'll be giving that link in the description. If you want to recall, means just go and see this clip alone. Okay, so the values which I did not mention in that video and some special cases alone we will be discussing in this video. So in all those beams, we saw the theta value, that is slope value, and deflection value at the ends only. So either at the free end or at the supports, like that. But at the center place, we didn't see that. Okay, so that is important for this structural analysis. So for all the same beams, we will be seeing the deflection in the center point, that is middle of that beam. So if you have that paper with you, means you can just add this itself in that. Okay, so that it will be easy for you to study. So in the same order only I'm going to tell now also. Okay, so the first is the cantilever beam with the moment at the end. So here the deflection at C will be ml square by 8 EA, and the cantilever with the point load at the end, the deflection at C will be 5 by 48 WL cube by EA, and cantilever beam with UDL throughout it, deflection at C will be equal to 7 WL power 4 by 192 EA. Okay, so don't get afraid of seeing all these formulas, because don't try to mug up these. Okay, so you see it repeatedly with your eyes, that itself will be enough for you. So whenever you take this chapter, you just see the formulas with your eyes and you just spell it out. Okay, so when you do the same thing repeatedly, automatically it will be stored in your brain. Okay, so don't put too much of strain to mug up these. So when you practice more and when you see the formulas again and again, it will be automatically easy for you to make it memory. So here a cantilever beam with UVL. So this UVL at the greater side at the support. Okay, so here theta B, so this we didn't see in that unit. So WL cube by 24 EI, and the reverse case, that is the maximum load at the free end, means it is WL cube by 8 EA. Okay, and then simply supported beam with the center load. So at that time the deflection at the center will be WL cube by 48 EA. Okay, and also I have given for D and E also, that is the quarter span here. So if the whole span is L, means this span will be L by 4. Okay, so both in D and E it will be same only. So it is 11 by 768 WL cube by EA, and then simply supported with UDL. So the deflection at C will be equal to 5 by 384 WL power 4 by EA, and the deflection at D and E will be 19 by 2048 WL power 4 by EA, and here the slope at A and B will be equal to WL cube by 24 EA, and then simply supported with a load at eccentricity, that is not at center. So it is PAB 2L minus A by 6 EIL slope at A, and slope at B it is PA L square minus A square by 6 EIL. So here the deflection is very important. Okay, so deflection C is equal to PA square B square by 3 EIL. And then a fixed beam with center load. So here the rotation theta will be always 0, because as it is a fixed beam, at the ends and at the center it is 0, and then the deflection at C will be equal to WL cube by 192 EA. Okay, so remember this by how, means it is 1 by 4th of the simply supported beam with the same case. Okay, so if you take the same case, that is simply supported beam with center load, means you will be getting a value. No, so when you take 1 by 4th of that value, you will be getting this value. And the same thing for the fixed beam with UDL also. So here it is WL cube by 384 EI. So this will be 1 by 5 times of the simply supported beams with the UDL. Okay, so there will be getting 5 by 384 like that. So 1 by 5 of that. So you can just remember this two fixed beams with the simply supported beam value. And then fixed beam with the point load at eccentricity, it is P A cube B cube by 3 EI L cube. Okay, whereas in the simply supported, you will be studying P A square B square like that. Similarly, it will be here. Okay, and then the next two cases are, so here it is a hinged support, that is at the left side it is a hinged support, and the other end, if it is hinged or pinned, either it may be both. Okay, if that is the case, means theta A will be ML by 3I and theta B will be half of that. Okay, so it is ML by 6 EI. So this case is very important. Here the deflection C, that is at the midpoint, it is ML square by 16 EI. And the second case is one end is fixed and the farther end is hinged or pinned, means it is ML by 4 EI at B. And deflection at C is equal to ML square by 32 EI. So these are the basic and important values to be studied. So the most important and which values are will be repeatedly using. So that alone I have written here. So studying this is enough. So get practice with this formula. So when you go into the method of analysis with different methods we have, no? So when you do that, it will be very clear for you. Thank you and keep watching for the next lecture on strain energy method.